Welcome to today's explainer. Inefficient electronic health records are literally costing the healthcare industry billions in lost productivity right now. And worse, they're a massive cause of physician burnout. So if you're a developer, an architect, or a healthcare executive tuning in, you already know that building clinical software isn't just about writing a few lines of code. It is about constructing a highly secure, specialized digital facility. And today, we're zeroing in on a highly demanding niche, building HIPAA-compliant ENT, that's ear, nose, and throat, clinic software, specifically tailored for the year 2026. We're going to look at how to build a system that's not just legally bulletproof, but actually makes specialists' lives easier. Okay, let's take a quick look at our architectural blueprint for today. We're going to cover the 2026 software mandate, dive into zero trust and security, unpack the FHIR interoperability standard, look at some ENT-specific features, go over the new accessibility rules, and finally wrap up with deploying future-proof systems. All right, part 1, the 2026 software mandate. The whole landscape of healthcare tech is shifting under our feet right now, and 2026 is shaping up to be this absolute, non-negotiable watershed moment. So I have to ask, is your healthcare software genuinely ready for 2026? Because honestly, if you're running on legacy systems or if your compliance strategy is kind of just a bolt-on afterthought, you're standing on incredibly thin ice right now. The rules are changing fast, and old systems simply might not survive. We're staring down what I like to call the 2026 convergence. Think about it. The FDA is clearing hundreds of new clinical AI tools every single year. Telehealth? That's basically the baseline now. Care delivery is fundamentally changing. But at the exact same time, we're getting hit with really strict new HHS accessibility deadlines. Oh, and don't forget the intense scrutiny under HIPAA and the HITECH Act around protecting EPHI, or electronic protected health information. You literally cannot just patch an old system to handle all of this at once. It requires a total architectural rethink.
Moving on to Section 2, Zero Trust and Security.
So the absolute foundation of modern security is beautifully simple. Never trust, always verify. Picture a modern ENT clinic, right? You've got clinicians logging in from tablets in the hallway. You've got connected Internet of Medical Things devices like endoscopes and telehealth platforms running 24/7. A zero-trust architecture means you treat every single one of those users, devices, and network paths as totally untrusted until they can prove otherwise. It's all about enforcing least privilege and using microsegmentation around those sensitive clinical systems. That way, if one tiny area gets compromised, the blast radius is immediately contained. No spreading like wildfire. Now, how do you actually build that in the real world? Well, you follow a rigorous step-by-step process based on the NIST risk assessment framework. First up, define the scope of your EPHI workflows. Basically, ask yourself, where does patient data live and where does it travel? Second, identify the specific threats and vulnerabilities. Imagine a compromised connected scope feeding unencrypted data straight to an iPad on an open guest Wi-Fi network. Not good. Third, honestly assess your current safeguards against those threats. Fourth, determine the real-world likelihood and the potential impact of those risks. And finally, step 5, implement mitigation strategies. We're talking multi-factor authentication everywhere and solid end-to-end encryption. This isn't just a compliance checklist. This has to be the continuous, living heartbeat of a secure clinic. Let's hit Section 3, the FHIR interoperability standard. Okay, let's demystify this acronym right out of the gate. FHIR stands for Fast Healthcare Interoperability Resources. It is a super modern, web-based standard created by HL7, and it uses standard REST APIs to exchange healthcare data as discrete elements, usually in JSON or XML formats. But here is the real magic of FHIR, the 80-20 rule. It provides these standard resources, things like patients, medications, diagnostic reports, that cover 80% of your common clinical use cases right out of the box. It just makes building these systems so much more efficient. The ultimate goal here is to totally smash those traditional data silos. By standardizing the APIs, providers can finally share data with confidence to coordinate care. Payers can pull the info they need without a massive headache. And honestly, the best part? Patients can actually take true ownership of their own health data through mobile apps. FHIR is essentially the universal translator that makes this whole interconnected ecosystem a reality. Now, for the architects and devs tuning in, you've got a really crucial choice to make here. You can either build a native FHIR server, which stores and processes all that data directly in the native FHIR format. Or, if you're stuck with a massive legacy database that you just can't rip out right now, you can build a FHIR facade. This facade acts like a middleman. It receives the modern FHIR API request and translates it into your legacy internal structure on the fly. It's an absolutely fantastic way to modernize an older system without taking on the massive risk of a full database migration. Diving just a little deeper into the technical weeds here, there are 3 core REST service interfaces you need to manage these data interactions on your server. First, you have iServe instance that handles your standard get, put, and delete actions on a specific patient's record. Then, you've got iServe type for metadata and searching across records. And finally, iServe system handles system-wide behaviors like processing big transaction batches. Structuring your software around these 3 interfaces is exactly what guarantees your system can actually talk to the rest of the healthcare world. Section 4. ENT-specific clinic features. Listen, generic electronic health records absolutely fail otolaryngologists. Seriously, imagine a specialized doctor trying to force complex audiogram results into a generic plain text box. It's incredibly frustrating, it wastes so much valuable clinical time, and it is highly prone to errors. An ENT clinic is an entirely different beast. You need custom templates built specifically for complex ear exams, throat cultures, and nasal endoscopies. Plus, ENT work is highly visual and auditory by nature. Your software absolutely must directly integrate with diagnostic equipment, so images and audio files are flawlessly automatically embedded right into the patient record. And hey, don't forget pediatric workflows. A busy pediatric ENT clinic needs child-friendly templates because diagnosing and treating a toddler is vastly different from treating a 50-year-old. If your software isn't doing this, you are actively slowing your doctors down.
All right, Section 5, Meeting 2026 Accessibility Rules.
I really need you to burn these dates into your memory, folks. Under Section 504 of the Rehabilitation Act, the HHS has mandated that healthcare organizations receiving any federal funding must make their digital assets accessible. Here's the timeline. If your organization has 15 or more employees, your hard deadline is May 11, 2026. If you have fewer than 15 employees, you get a slight extension until May 10, 2027. And to be clear, this applies to everything. Your patient portals, your appointment scheduling tools, your telehealth platforms. This is not optional anymore. So how do you actually make sure you comply? Well, you build exactly to the WCAG 2.1 AA standards. First, your software must be perceivable. That means things like descriptive alt text on images for visually impaired patients and highly accurate captions for telehealth videos. Next, it must be operable. Think about a patient with severe motor impairments. They literally need to be able to book an appointment using only a keyboard. Third, it needs to be understandable. You want crystal clear error handling on all your digital forms so no one gets confused. And finally, robust. The platform has to play nice and be fully compatible with external assistive technologies like screen readers. This level of accessibility, you can't bolt it on at the end. It needs to be baked into your UI and UX design from day one. And finally, Section 6. Deploying future-proof systems. You know, beyond all the code and the tech specs, we really have to remember the humanity of what we're building here. Ultimately, accessible digital healthcare ensures that every single patient, regardless of their ability, can access vital health services with dignity and independence. When we get bogged down talking about zero trust, FIR APIs, and WCAG standards, it can sound pretty dry, right? But the actual end goal of combining strict security compliance with inclusive design is compassionate care. We're building systems that lock down a patient's most sensitive data while simultaneously ensuring they can actually access the care they desperately need exactly when they need it. So I want to leave you with this final, somewhat provocative thought. As we look ahead to the massive tectonic shifts coming in 2026, really ask yourself, is your clinic software a liability or is it your greatest competitive advantage? Because those who treat HIPAA, zero trust, and accessibility as just annoying burdens are going to be left scrambling. But if you embrace this architectural blueprint, if you design specialized, highly secure, interoperable, and fully inclusive software, you aren't just ticking off a compliance box. You are literally building the future of healthcare. Thanks so much for joining me on this explainer, and hey, happy building!